This is Algebra 2 with Trig, working on 8b.3b. We're looking at some patterns that are true about the unit circle. When we've talked about the unit circle in the past, we've discussed how there's different coordinates, or the same coordinate really, different angles with the same exact coordinate. We're looking for all the radian values that have a denominator of 4. So when we take our unit circle, I see a radian value that has a 4 in it. I see a radian value with 4. I see a radian value with 4. And a radian value with 4. We have 4 different spots where this is happening. The obvious one is pi over 4. What degree is happening at that angle? That is a 45-degree angle. What is the coordinate at that location? That's where we put our fun little triangle right in here. That a 45, 45, 90 triangle with a radius of 1 is going to have sides that are called root 2 over 2. So your x and your y are exactly the same, because it's a 45, 45, 90 triangle. Legs are congruent. They're both going to be root 2 over 2 for x and y. So your ordered pair is root 2 over 2, root 2 over 2. That's going to be true for any 45, 45, 90 triangle. So what's another 45, 45, 90? Well, if you added 45 to this, you'd get 90 degrees. But 90 degrees would be 2 pi over 4, and that's reduced to pi over 2, so that's not it. What's another one that ends in 4? That would work, but let's just go in order. So this is 1 pi over 4. 2 pi over 4 reduces. 3 pi over 4 is your next one. Three pi over 4. That would be 45, 45, and another 45 degrees.
So all of these would basically be the center point between 90, or like, you know what I mean?
Every time we go 45, we are always the center point between our two coordinates. Every time. So this is 135 degrees. Our coordinate, because we're thinking about x comma y for our coordinate, x is to the left, y is up. So that's negative root 2 over 2, root 2 over 2. We need another denominator that ends in 4. So if we go 45 more degrees, we'd come down here to 180. But it gets reduced, so we do another 45 degrees. So we get to 225 degrees. 1/4, 1 over 4, 1 pi over 4, 2 pi over 4 gets reduced, 3 pi over 4, 4 pi over 4 gets reduced, 5 pi over 4. That one can't be reduced, so we're going to write that one down. 5 pi over 4. So that's 225 degrees. That's going to have the exact same coordinates again. Your x is root 2 over 2. Your y is root 2 over 2. Your x is negative. Your y is negative. So we write down our coordinates. This one's in the first quadrant. That's in the second quadrant. This is in the third quadrant. What's the one in the fourth quadrant? This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This is 5 pi over 4. 6 pi over 4 would be straight down. It got reduced. So now we're at 7 pi over 4. And that's 315 degrees. And that's going to be to the right. So it's positive. It's going to be down because it's negative. Let's take a look. We're going to the right to get to this point. We have to do x's first, and then we do y's. So notice that all of these coordinates were exactly the same. All the 45s, all the ones that end in 4s, are going to have the same coordinates. They just change by positives or negatives. The positives and the negatives are all determined by graph paper. This is zoomed in graph paper. We've talked about that before when we tried to discuss how the unit circle was zoomed in right on graph paper. So positive, positive, these are all going to be positive, positive. Left up is going to be x is negative, y is positive. Let's move on to numbers that are having denominators of 3. Well, the first one's pretty clear. Pi over 3. What's the angle at pi over 3? Everyone should have a clue. 60 degrees. So when we think about our triangle that goes to that 60 degrees, we have a short side, which is called the half. We have a long side to get way up there to the top, which is always root 3 over 2. Short, long. That's how you get to this location. You go over a short distance, you go up a long distance. So the short number, the smaller number, and then the larger number. Then we have 2 pi over 3. 2 pi over 3 is going to be your second pi over 3. It's going to be 60 and your second 60. It's going to be 120 degrees. To get there, we're going to do x as a negative value and y as a positive value. Short, long. I would always look for numbers that are short, long, sides of the triangle. You'll find those in every 30, 60, 90 triangle. 2/3 of all of these are all made up of the 30, 60, 90 triangle, not counting the quadrantal angles. 3 over 3 would be at pi. We're not going to talk about that one because it gets reduced. 4 over 3. That's 60 degrees past 180. $240 degrees. 240 degrees, remember you got to hang your triangle on the x-axis. X comma y. X is negative, y is negative. Short, long. X is negative, y is negative. Short, long. And then we have our last one. We have another 60 degrees. That brings us over here. So we have pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. Count your way around it. So that's 300 degrees. That's over a short distance for x, which is positive, and it's down a long distance for y, because your short is your x in this case, and your long is your y to get way down here, towards the bottom of the circle. So notice how all of these coordinates are exactly the same. It's not a coincidence. They're all 60 degrees from the x-axis. When you put in our triangle here, they're all 60 degrees here at the origin. 60 degrees from the x-axis. Now we're going to do denominators with the 6. Well, that's clearly pi over 6. We're going to take pi, we're going to break it up into 6 equal pieces. So this is one of those 6. In terms of a degree, since pi is 180, we're going to divide 180 up into 6 equal pieces. We get 30 degrees. That's pi over 6 is 30 degrees. We're going to lay our triangle on here, so the 30 is at the origin. It's a 30-degree angle. Now we're looking at x values that are long and y values that are short. Long, short. So long to the right and short up, they're both going to be positive. Now if you were to do a second pi over 3, like 2 pi over 3, you would get 30 degrees more, but that can be reduced. 2 pi over 6 can be reduced. Did I say that wrong the first time? This is pi over 6. This would be 2 pi over 6. It can be reduced, so we're not going to count it. 3 pi over 6, which is 30 degrees more, we're not going to count it. 4 pi over 6, that's 30 degrees more, we're not going to talk about it right now. 5 pi over 6, we're 30 degrees from the x-axis. We're looking for 30 degrees from the x-axis. We're at this coordinate. We're left a long way, up a short way. That was 5 pi over 6. That was 30 degrees from the x-axis, 30 degrees from 180. So we're over a long way, we're up a short way. Long is always root 3 over 2, short is always a half. So when you visualize that, long is to the left because we're going over almost all the way, and up a short way to get to this 150 or a pi, 5 pi over 6. 6 over 6 would be pi. 7 over 6. 210. So that's to the left a short, or over, left a long distance, down a short distance. "30 degrees past the x-axis is over a long distance, down a short distance to get here." And then 11 pi over 6. That's going to be 330 degrees. 30 degrees from the x-axis. That's 30 degrees less than 360. You're over a long way, you're down a short way. long is root 3 over 2, short is a half every single time. In this case, the x is positive, but the y is negative because you're going in the fourth quadrant. On the flip side, all the radian measures with a denominator of 4, the degrees measurements have degree measurements that are multiples of 45. If you multiply 45, you'll get to all of those. Their ordered pairs are always root 2 over 2, root 2 over 2. The only thing that's going to be different is the plus or minus. All the radian measures with the denominator of 3, and we talked about those, denominator of 3, denominator of 3, denominator of 3, they all have degree measurements that are multiples of 60 degrees. And their ordered pairs are over a short distance and up a long distance. Short, long. That's going to look like this. So every one that has a denominator of 3 is 60 degrees away from the x-axis. They're all short side, long side, x, y, horizontal, vertical. And they only vary by plus or minus depending on which quadrant they're in. To the left is negative x's. Up is positive y's. Left and down would be negative, negative. Right and down would be positive, negative. Denominators of 6. Are multiples of 30. And they're all going to be root 3 over 2, 1/2. Let's take a look at y. Multiples of 30 are all denominators of 6. 30 degrees away from the x-axis has a denominator of 6. 30 degrees away from the x-axis has a denominator of 6. And they're all long, short. Long for the x, short for the y, root 3 over 2, comma, half. The only thing that changes is their plus or minus. Changing from degree to radian. Now, we're not trying to multiply this out. We're not doing the conversion factor. 225 degrees. This is what you're thinking in your mind. I realize that this is more than 180. This is less than 270. This is 45 degrees more than 180. That gives you 225. So it's in the 45s. It's made of pi over 4. This would be 2 pi over 4. This one here would be 3 pi over 4. Straight across would be 4 pi over 4. So this is clearly 5 pi over 4. That's the radian that goes in that direction. 5 pi over 4. 120 degrees. Well, I know you have 30, you have 60, you have 90, you have 120. You're over a short distance. You're up a long distance to get there. So you're way up high for 120. $30, $60, $90, $120. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which can be reduced to 2 pi over 3. So I realized that it was made up of 30s. You could have said that it was made up of 60s. A 60 and a 60 makes 120. So pi over 3, 2 pi over 3 would have been the shortcut. Okay, let's take it and turn it into a degree. Where is 11 pi over 3? Or 11 pi over 6? Well, you can talk about the sixes. That's 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7 over 6, 8 over 6, 9 over 6, 10 over 6, 11 over 6. Remember, notice that we skipped the middle one every time. That's always the multiple of 45. So we skip that one. 1 over 6, 2 over 6, 3 over 6, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. I didn't just look at the chart. I determined it by counting. So that's 330 degrees. That's 30 degrees away from 360. Where is 3 pi over 4? Well, count your way there. This is 1 over 4. That's 2 over 4. That's 3 over 4. These are fourths. So that's 45 degrees less than 180. Or even 45 degrees more than 90 in this case, since it's right down the center. So that's 135 degrees. I did not use a conversion factor. I did my understanding of where it is. One-fourth, 2/4, 3/4. 45 degrees away from 180. What angle has this? I don't know. I got to think about it. This says a negative direction. This says a positive direction. Because the values are both the same, I know it's in the 45s. So I know that's 135 degrees. 45, 45, 45. Pi over 4, 2 pi over 4, 3 pi over 4. One comma 0 would be straight across. So that's going to be at 0 degrees. You could say it's at 360 degrees. You could say that it's 0 pi. And you could call it 2 pi. Left a half, so it's left a short distance, down a long distance. So you're way down here. So you're not short down, you're not medium down, you're long down. You're 60 degrees away from the x-axis. So that's 240 degrees. 60 degrees, that's made up of the pi over 3s. 1/3, 2/3, 3/3, 4/3. 4 pi over 3. Count your way there. To be at negative a half, negative root 3 over 2, you're way down here. So being way down at the bottom, you're the most away that you can get without getting down to the 90. So that's the 60. So we go pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. I'm sorry, over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. That's better. All right, evaluate. What evaluate's saying, without any calculators, 0 degrees is coming straight across. The coordinates at that location are 1 comma 0. Sine, remember we always go in order of, it's alphabetical. So cosine goes first, sine comes second. So at 0 degrees, sine is 0. 210. 210 is 30 degrees away from the x-axis. The coordinate here is long, short. Long, short. Goes right there. So cosine is your x value. So the answer is negative root 3 over 2. Tangent of 180. 180 is over here. This is negative 1 to the left and 0 up. Tangent is the y value over the x value. The sine over the cosine. The y over the x. The 0 over negative 1, which is just 0. Two pi over 3. This is an angle. This is 1 over 3. This is 2 over 3. That's way up there. So our coordinate is over a half, up a lot, short, long. So we're looking for the y value. So we're looking for root 3 over 2. Seven pi over 4. I know that over 4 is the 45s. So this is 1 over 4, 2 pi over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, 7 over 4. It's pointing in that direction. That is root 2 over 2 and negative root 2 over 2 because it's positive, negative. So the cosine, the x value, is root 2 over 2. Tangent. Tangent. Where's 11 pi over 6? This is 1 over 6. 2 over 6 is 30 degrees more. 3 over 6. 4 over 6, 5 over 6, 6 over 6 would be 1 pi, 7, 8, 9, 10, 11. So that's a long way over and a short way down. Long way over and a short way down. So we're looking for the tangent. So negative 1/2 divided by the y value divided by the x value. So the way you do this is take your y times the reciprocal of the x. Reciprocal of the denominator. That gives us negative 1 over root 3. So negative 1 over root 3, we have to rationalize the denominator, and we get negative root 3 over 3. And that's our answer. All right, everybody.